Welcome back to the deep dive. You've given us the sources, and we are ready to take this deep dive into, well, the architecture and strategy behind successful projects.
That's right.
And if you're new to the world of development or maybe just starting a major project, this session is really custom tailored for you. This is the second step in our series on configuration management.
Yeah, we're building that foundation for a sustainable, successful build.
Last time, we focused entirely on the user right. We talked about capturing every single user requirement, storing those wishes in an organized, atomic way, ready to be acted upon.
Exactly. We figured out what the driver wants the car to do.
And now comes the crucial pivot. Our mission today is to move out of that purely conceptual world of requirements and cross the bridge into the planning phase.
This is the big one.
This is where we stop asking what and really start defining how. Because if we fail here, the whole project just risks collapsing.
And that risk is the key thing, We need to emphasize that right up front. The number one rule has to be planning must happen before the first line of code is written.
Not after.
Never after. If you rush into coding because, the users are getting impatient, you're absolutely setting yourself up for the biggest project failure imaginable. And that is the catastrophic redesign.
Okay, so paint a picture for us. What does that catastrophic redesign actually look like in practice?
Well, it happens when you deliver the first phase, and suddenly the project requirements shift or expand, which, let's be honest, they always do.
Always.
But because you didn't plan the foundation properly, you didn't choose the right engine for the car, that simple little shift in direction requires you to tear down everything you just delivered.
Oh, wow.
You have to scrap the structure, re-platform the entire system, and start over. It's a complete waste of time and budget, all because the underlying architecture just couldn't handle the new reality.
That makes the stakes incredibly clear. So, okay, if we're defining the architecture, we first need to understand the environment. We've got our atomic requirements locked in. I imagine the first hurdle isn't writing code. It's realizing the new system won't live alone, right?
Absolutely. The age of, isolated projects is long gone. When a project becomes a system, it has to operate within an ecosystem. You must assume it will require interconnectivity.
It's talking to other things.
It's either accepting data streams from other legacy systems, or it's passing formatted data out, whether that's to end users or, more often, back into yet another system.
So that forces a massive shift in focus. The planning phase becomes fundamentally all about the data.
It is.
We're moving from the aesthetics of the user interface to the mechanics of the engine block.
Exactly. This is where the engineering mindset really has to take over. You have to map the internal mechanics of that atomic user requirement.
Okay, so what are the questions?
You have to ask a series of deep questions. What data is this project actually going to operate on? How should that data be stored and manipulated efficiently? And is this data going to be used for, say, complex long-term historical reporting? Because that requires a totally different schema.
And I guess most critically, are we going to feed this manipulated data into another system down the line? Because if system A depends on system B and B changes its data format, we have a failure point we need to anticipate right now.
We do, and this is the gap. User requirements rarely, if ever, define how data is stored or internally manipulated.
Right. They just know what they want to see.
They tell you what they want to query, what buttons they want to click, and what numbers they need to see on the screen. They focus on the output. Our planning phase has to focus on the input, the manipulation, and the storage. All the parts the user never, ever sees.
I see. So the actionable insight for you, the listener, is that the process of thinking through these structural data questions, storage, manipulation, performance, will absolutely expose holes in the original user requirement.
And this is where we have to be disciplined. You have to expect, during this planning phase, to add considerably to the existing list of requirements in your requirements management system.
You're adding new things.
Many new things. If you realize your data needs, say, international character sets, but the requirement never specified global users, you must add that requirement now. I once saw a team realize 6 months in that their original data schema couldn't handle international character sets.
Oh, no.
6 months of work, gone, tossed out because of poor data foresight.
That's a staggering cost for what seems like such a small detail. Okay, so we're adding these new items to the system. They aren't for the users, they are for the builders. These additions, these are the technical requirements.
That's the critical distinction. Technical requirements are dependencies for the user requirements. They define the security, performance, logging, the infrastructure, everything necessary to deliver the feature the user actually asked for.
So without the technical requirement, the user requirement is just a wish?
Just a wish. And this phase demands we make firm infrastructure decisions.
Okay, so we've defined the internal engine. Now we need a garage to put it in. What are the big infrastructure questions we have to answer right now before we even hire the team?
We're defining the environment. Will this system live on newly purchased physical hardware? Are we extending existing, maybe aging virtual server systems? Or are we going full cloud and adding significant resources to an existing cloud infrastructure?
And these decisions have huge cost and time implications.
Enormous. They have to be factored in now.
And then we get specific about the data itself, right? The database considerations. You mentioned performance and volume. How do those three criteria, type, performance, and volume, how do they define your technology stack?
Let's break that down. If you need transactional integrity, I mean, absolute certainty that every entry is recorded correctly, you might opt for a traditional SQL or relational database.
Okay.
But if the system needs to store vast amounts of flexible, unstructured data, say millions of log entries every day, NoSQL data lake might be the better and frankly cheaper solution. The type defines the foundation.
And performance. What does exceptionally performant really mean when you're planning?
It means we can't rely on spinning disk drives. It probably means we need in-memory caching systems, specialized hardware, or maybe even distributed database clusters.
A user asking for a single button-click response time
is actually generating a technical requirement for high-speed infrastructure. That's why we need to make that connection explicit in the requirement management system.
That's a fantastic way to link the user's wish directly to the project's cost. So once we finalize those technical decisions, the language, tools, architecture, the focus shifts to logistics and people. What are the most critical resource questions here?
First is capacity and capability. Do we have enough staff with the right skills to deliver on this architecture on time? If we just decided we need a specialized, exceptionally performant database, do we have an engineer who knows how to set up and manage it?
And if the answer is no, what's the trade-off? Hire someone new. Train existing staff.
That's a really common dilemma. If the specialized skill is only needed for, say, 3 months, looking at contractors or short-term consultants is often faster and more cost-effective.
Right, because hiring a full-time specialist can take 3 months just in recruitment.
Exactly. The planning phase has to decide on that financial and time-based trade-off. We also have to identify what programming and database tools we need to obtain that we don't already have.
And here comes that inevitable moment of truth, the collision with the customer's timeline. We now have a list of technical dependencies, new hardware, new staff, new tools that were not there when the customer initially set the delivery date.
Correct. The planning phase forces that realism. If we found out that the required infrastructure upgrade, that massive server farm for the database, will take 6 weeks to procure and set up, well, that 6 weeks must be added to the project calendar.
So you have to have that difficult conversation now.
It's so much better to have it now than 6 months into development when the project is already hopelessly behind.
So connecting this all up, by the end of this planning phase, the goal is total clarity. The technical gaps are filled. We have firm decisions on the tech stack, on the resources required.
And we can then transition from that concrete list of requirements, both user and technical, to structuring the actual work. We review those requirements and prepare the time boxes.
You mentioned time boxes. Can you clarify the difference between a time box, a phase, and just, a to-do list?
A time box is a container. It's a collection of those atomic level requirements grouped together specifically to define the order of development and tied to a fixed calendar period.
Okay.
So it isn't just a list, it's a committed volume of work against a strict deadline. Many modern methodologies call these sprints, defined by, say, a 2-week period during which the team commits to completing that specific group of requirements.
But hold on. If we spend all this time planning and estimating, doesn't that inherently go against the flexibility promised by Agile? Isn't over-planning just the new waterfall?
That raises an excellent point. It is a balance. We are planning the structure of the requirements, not coding every little detail. The structure, the architecture, should be rigid enough to hold the weight, but the contents of the time boxes have to remain flexible.
You plan for flexibility.
Exactly. Because reality dictates that a requirement that seems straightforward on paper often turns out to be anything but simple once a developer starts building it.
If a requirement proves far more complex than we thought, how does that flexibility mechanism work inside the time box system?
Well, that inherent complexity means a single problematic requirement can have a cascading effect on the schedule. If it's blocked or it's taking 3 times longer than estimated, the project manager has to make a tough call.
What are the options?
Either the team misses the delivery date for that sprint, or the problematic requirement gets moved to a later sprint or phase. That allows the team to complete the rest of the committed work on time. The time box itself is fixed. The work inside it can be movable.
This just highlights why involving developers during the planning phase is so critical. We need their expert judgment. Why wait until they start coding to discover that time bomb?
Involving them early achieves several critical things. First, it gives them an overall view of the project, which generates buy-in and ownership.
Right.
Second, you use their experience to hopefully uncover some of those problematic requirements before they get locked into a time box. And maybe most importantly, developers are the ones best suited to accurately estimate the time to complete each requirement. Their estimates are the concrete foundation of your final project timeline.
Okay, so the developers provide those crucial time estimates. The technical and resource puzzle pieces are assembled. The project manager and their team can now use those estimates to build out the master project timeline.
This project plan timeline is the roadmap for the entire delivery. It details start and end dates for every sprint, every phase. But here's the critical point. This must be treated as a living document.
It's never static.
Never. It has to reflect reality, right? If that straightforward requirement suddenly took 3 weeks instead of 3 days, the timeline needs to absorb that shock and show the new projected end date.
Right. It's your key measure of velocity.
Precisely.
Yeah.
Is the project on time or is it running behind? If you are tracking requirement completion and updating that timeline weekly, you have an accurate picture. If you let it stagnate, you are flying blind.
And once all these steps are complete, the capture, the architectural definition, the scoping, allocation, and timeline, the foundation is secure.
And that means we are officially ready for the development phase.
Which will be the subject of our next deep dive.
The handoff is complete. We know what to build, and crucially, we know how to build it.
So, what does this all mean for you? The key takeaway from this deep dive is that comprehensive planning, specifically focusing on defining technical requirements and data architecture, is your primary defense against that catastrophic redesign.
It's an investment.
It is. It's the investment that saves you 10 times the effort later. We have to define how the engine works before we commit to what the driver sees.
And this raises a really important question for you to think about, one that connects that technical dependency all the way back to the schedule. If those initial developer estimates during planning uncover a non-negotiable infrastructure upgrade like needing that specialized performant database we talked about, how does that single technical dependency ripple through the entire system? How does it force budget renegotiation, change your hiring timelines, and ultimately invalidate the customer's initially realistic timescale?
Technical decision is the schedule decision. A powerful thought to chew on. Thank you for joining us as we navigated the critical planning phase, get those technical requirements locked down, and prepare for the next step, the actual development phase. We'll see you next time. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.